Hello everybody and welcome to the Calgebra 1 video. Please watch this video to complete the Calgebra 1 section of your independent study packet. The section is due on July 23rd. Remember, you have the ability to fast forward or rewind or pause during this video. Turn to part 1. We're going to simplify the following complex fractions. First, we can rewrite the problem. When we do this, I like to include my denominators, so I'll put 1 over 1 and 2 over 1. When I look at the 1, the 2, and the 4, I notice that the least common denominator here is 4. To simplify this complex fraction, we're going to multiply the numerator and the denominator by 4. Notice that when we're multiplying by 4 over 4, we're really just multiplying by 1, so nothing's changing. If you find it helpful, you can put 4 over 1, 4 over 1. So now it's time to distribute. 4 times 1 is 4. 4 times 5 halves is 10. And 4 times 3/4 is 3. In the denominator, 4 times 2 is 8, and 4 times negative 1/4 is negative 1. Now you can see that the final answer is 17/7. For an example like this, you can always check your answer using your calculator. Number 2. First, rewrite the problem. While you're rewriting the problem, include your over 1 and over 1. Now I'm checking out 1x and x squared, and I'm noticing that the least common denominator is x squared. So we're going to multiply the numerator and the denominator by x squared. If you find it helpful, put x squared over 1. Now it's time to distribute. X squared times 1 is x squared. X squared times negative 3 over x is negative 3x, and x squared times negative 10 over x squared is negative 10. In the denominator, once we distribute, we'll get x squared plus 11x plus 18. Now we should notice that we can factor in the numerator and the denominator. The factors in the numerator are x minus 5 and x plus 2. The factors in the denominator are x plus 9 and x plus 2. Now you can see that the x plus 2's cancel. So we get x minus 5 divided by x plus 9. For the purposes of this packet, we'll say that this is where we can stop, but there are some domain issues that we should keep in the back of our mind. The original expression is undefined when x equals 0, so therefore x cannot equal 0. Also, the original expression is undefined when the denominator equals 0, so therefore the denominator cannot equal 0. Now if you solve this inequality, you'll see two more domain restrictions. X cannot equal negative 9 and x cannot equal negative 2. That means that our original expression implies three things. X cannot equal 0, x cannot equal negative 9, and x cannot equal negative 2. Now look at our simplified expression. Here, the denominator cannot equal 0. So our simplified expression implies that x cannot equal negative 9. Notice that on both sides it's implied that x cannot equal negative 9. So technically the following conclusion can be made. The original expression equals x minus 5 divided by x plus 9 when x is not equal to 0 and when x is not equal to negative 2. The reason why we need to put these domain restrictions is because now on both sides it's implied that x cannot equal negative 9, x cannot equal 0, and x cannot equal negative 2. For the rest of this packet, we are going to ignore the domain restrictions, and we're just going to focus on obtaining this final answer right here. I just wanted you to be mindful that there are domain restrictions involved. Number 3. First, rewrite the expression. Now, put in your over 1's. The least common denominator is 2x plus 3. So, multiply the numerator and the denominator by 2x plus 3. And if it helps, put your over 1's. Next, it's time to distribute. In the numerator, we get x times 2x plus 3 minus 4 times 2x plus 3 plus 9. In the denominator, we get x times 2x plus 3 plus 3 times 2x plus 3 minus 5. Now we're going to simplify. In the numerator, we get 2x squared plus 3x minus 8x minus 12 plus 9. In the denominator, we get 2x squared plus 3x plus 6x plus 9 minus 5. Now it's time to combine like terms. We'll get 2x squared minus 5x minus 3, all divided by 2x squared plus 9x plus 4. We can factor the numerator and the denominator. In the numerator, we get 2x plus 1 times x minus 3. In the denominator, 2x plus 1 times x plus 4. We see that the 2x plus 1's canceled, so our final answer is x minus 3 divided by x plus 4. Number 4. First, we're going to rewrite the expression. And we can make sure we put an over 1. The LCD here is x times x plus h. We're going to multiply the numerator and the denominator by x times x plus h. You can put over 1 if it helps. Now we're going to distribute. If we distribute here, we see that the x plus h's cancel, so we're left with x. When we distribute here, we see that the x's cancel, so we're left with minus the entire quantity x plus h. Parentheses are extremely important there. We have to subtract the whole quantity x plus h. In the denominator, don't try and multiply anything out, just leave it. X times x plus h times h. In the numerator, we're noticing that we can distribute a negative. So we get x minus h divided by x times x plus h times h. In the numerator, x minus x cancels, so you're left with negative h. In the denominator, we still have all this stuff. Now, the h's cancel, so we get our final answer, negative 1 divided by x times x plus h. Mental note, on this step right here, we are not allowed to just cancel the x plus h's. That is against the math laws. For number 5, we have to recall what x to the negative first means. This means 1 divided by x. Also, x to the negative 2, that means 1 divided by x squared. So when you're looking at 4 times x to the negative first, you're really looking at 4 times 1 over x, which is 4 over x. So first, we're going to rewrite this expression. We have 4 over 1 minus 4 over x plus 1 over x squared. In the denominator, we have 4 over 1 minus 1 over x squared. The LCD is x squared. So that means we're going to multiply the numerator and the denominator by x squared. And it helps if you put over 1. Now we're going to distribute. We'll get 4x squared minus 4x plus 1. In the denominator, we'll get 4x squared minus 1. Both the numerator and the denominator are factorable. In the numerator, we get 2x minus 1 times 2x minus 1. In the denominator, we get 2x plus 1 times 2x minus 1. So now we can see that the 2x minus 1's cancel, and we're left with our final answer, 2x minus 1 divided by 2x plus 1. Okay, so now you can complete 6 through 15 on your own. Please remember to check your solutions with the final answers on the back. For part 2, we're going to rationalize the denominator. The directions tell us to remove the sum or difference from the denominator by multiplying the numerator and the denominator by the conjugate of the denominator. Before we begin, we should remember that root x times root x is root x squared, which is just x. The square root of x minus 2 times the square root of x minus 2 is x minus 2. Another quick example, root x squared plus 6 times root x squared plus 6 is going to be x squared plus 6. So for number 1, to rationalize the denominator, we're going to multiply by the conjugate. What I mean by that is we're going to multiply the numerator and the denominator by 1 plus the square root of x squared plus 1. Notice that when we do this, we're really just multiplying by 1, so nothing is really happening. In the numerator, we can distribute the x. We'll get x plus x times the square root of x squared plus 1. In the denominator, we can use the first-last multiplying technique. So 1 times 1 is 1. We'll get a minus. And then root x squared plus 1 times root x squared plus 1 is x squared plus 1. We have to use parentheses here because we need to subtract that entire quantity. So in the denominator now, we're going to distribute the negative. In the denominator, we'll get 1 minus x squared minus 1. Now, the 1's cancel. So in the denominator, we'll get an x squared. We can simplify further. Let's rip the fraction apart. Now we can see that we can take out an x in both parts. So our final answer will be 1 over x plus root x squared plus 1 over x. Another equivalent answer would be 1 plus the square root of x squared plus 1, all divided by x. For number 2, we'll start by multiplying by the conjugate. In this case, we'll multiply the numerator and the denominator by the square root of x plus 2 plus 2. In the numerator, we get x squared minus 4 times the square root of x plus 2 plus 2. But in the denominator, we can use the first-last multiplication technique. So, root x plus 2 times root x plus 2 is x plus 2. Negative 2 times 2 is negative 4, so we get a minus 4. In the denominator, you can combine like terms. So 2 minus 4 is negative 2. You end up getting x minus 2. Now we're noticing that we can factor the x squared minus 4 in the numerator. Once we factor, we're noticing that we can cancel the x plus 2's. So our final answer will be x plus 2 times the square root of x plus 2 plus 2. Number 3, first we're going to multiply by the conjugate. In this case, we're going to multiply the numerator and the denominator by x minus the square root of x squared plus 1. In the numerator, we can distribute the 2. And in the denominator, we can use the first-last multiplication technique. X times x is x squared. We'll end up getting a minus. And root x squared plus 1 times root x squared plus 1 is x squared plus 1. Make sure you use parentheses because you need to subtract that entire quantity. In the denominator, distribute the negative. You will get x squared minus 1 Now the x squareds cancel. In the denominator, you'll get a -1. If you find it helpful, you can rip apart the fraction. Now you can more easily see that 2x divided by -1 is -2x, and also negative divided by negative is positive, so you'll end up getting positive 2 times the square root of x squared plus 1. Okay, so now you can do 4, 5, and 6 on your own, and don't forget to check your solutions with the final answers on the back.